Hi everyone, Solomon here. As promised, I created this short video on the device I've been developing. This is the device that detects sleep apnea. It's just like a sleep apnea detection device. I'm hoping um, this short video will open up a conversation with everyone, including engineers, health innovators, uh, on how we can just improve it, make it available. Uh, so you may ask, what's in it? What is the motivation, and what's the problem? You may know that sleep apnea affects millions of people all over the world, um, and detection often is very complex and expensive. So I hope this device will be used by any individual at the comfort of their home, and that is the ultimate goal of uh, this device. So I will go ahead and demo the hardware design, the system design, and after that, if you have any question or comment, you can send it to me, and we can talk uh, about it more. And hopefully, uh, uh, that will open up an opportunity to make it better or improve the system. All right. Okay. Let's go for it. Okay. A quick demo on this device, the apnea detection device. I'll try to make it uh, as quick and short as possible. Starting from the processor, um, I use this ESP32 SoC microcontroller with integrated dual mode, Wi-Fi and Bluetooth. It features dual-core 32-bit processor operating at about 240 megahertz. It's incredibly low price for what it does. And you can get up to 38 programmable GPIOs for anything you need in the IoT area. Micro USB for data transfer and power. You can get 5-volt power through this using USB. And then you have differential pressure sensor, positive and negative ports connected to one of the ESP32 IOs. That differential sensor it can withstand pressure from negative 0.3 to positive 0.3 psi. A pretty good range, to do for you to do whatever you want to do. Output 0.5 to 4.5 volt DC voltage, and you also have a wake up buzzer alarm module. It's designed to wake up the user when the pressure threshold is not crossing, which means if it's not crossing, there's not enough pressure, which means there's no breathing. So that there is a default threshold we set, but users can edit the threshold through the GUI, and the GUI application I will explain that, and I'll demo that. There's a snooze button here, a small button, which will stop the alarm temporarily. By default, it has about 120-second snooze time. The length of snooze time can be set or edited on the GUI app. The display board. If I can turn on the power, I need to connect that to the switch, but for now, I'll do this. So you can see the display for basic information such as pressure level, warm-up time, apnea time, and also battery power, basic informations. All this information also available on the GUI. So, and you have rechargeable battery, 3.7 volt, voltage regulator. This voltage regulator feeds stable 3.3 volt to the sensor and the ESP32 processor. Power boost 1000C. This power boost 1000C is used to charge the battery through this USB port. So this is it. So what we have right now, the warm-up time is done, and it will turn the buzzer on after 15 seconds. And I'm going to show you the GUI. Right now I'm breathing. You can see. Let me zoom out, and then so they can see. So when you have a big pressure, because I'm breathing right now, if I stop breathing in 15 seconds, it will so you can see that the line, the red line, it's not detecting any pressure. So that should turn on the buzzer, and I'm gonna just breathe again. You can see the positive and the negative pressure. The positive is the one at the top. You can see the top pressure, and then the lower one is the negative pressure. So inhale and exhale. Exhale the top one, the positive one. Inhale is a negative one. So this is a quiet pressure. Actually, it's quite good because the threshold, you can see the light blue between this lines right here. These are the thresholds. So a quiet breeze gives you that enough signal. If you do a normal breeze, it goes high. Stop breathing. When you stop breathing after 15 seconds, it will, because the apnea time is set to 15 seconds. You can edit this, lower it, but by default we set it at 15. So pretty much this signal is very strong signal. It picks up all the quiet breezes. So what else do we have here? So you can see when you have, I'm gonna, for now, I'll just disconnect this. You can see when you have an apnea time, the 15 second, for 15 seconds, I was not breathing. When I say I was not breathing, I was just breathing through my mouth. So if you're interested exactly how the cannula is connected to my nose, I just want to, you can see it's in my nose. That's how I breathe. So if I breathe through my mouth, there's no pressure. So that's why I created the sleep apnea time. So since the algorithm is working pretty good, and we can add both nose and mouth breathers too. So in short, the threshold can be set here. The snooze time, you can set lower the snooze time or just increase the snooze time, doesn't matter. The history of the graph, you can just slow down, and or if you want to make it faster time, you can just lower it to about 10 seconds or 20 seconds, so it will go faster. But if you want to read the detail of the graph, you can just slow you can make it slow. So that's why I put that 60 second. The battery, it shows you what the voltage of the battery that you have and what percentage of power you have. If you whenever you reach like 10% or less power, you will get a warning icon. So that's just to alert you that you need to recharge your battery. And if you want to just apnea time, it's 15 seconds now, but you can edit that to whatever time is appropriate for you. You could there are some people are just are quiet breathers, and some people they breathe really hard. So depending on that, you can adjust that. But by default, we just put a 15 second. You can log this data. You can start log, and it will create a CSV file. And that CSV file, you can use that CSV file to analyze, the breathing activity, right? So start log, wait, probably just collect it for about 5 minutes, and uh, stop the log and analyze all the data that you have. So this is a short explanation of this how this device works, including the app. Uh, this GUI app is available on desktop and on a smartphone. So if you have any question or comment, just send it to me, and based on your comment and questions, I can create another video. And so together we probably we can improve it. We can improve. So make it available. This an inexpensive device. My hope is just to make it very inexpensive and make it available for anyone at home. It's not a medical device. It's not a diagnostic, but it's just a detection device, whether or not you have apnea, without going through too much problem or without spending too much money. Okay. All right. I appreciate for your input, and we'll talk to you next time. All right. Bye.